Alrighty, section 2.5 is all about similar figures. And similar figures are figures that have the same shape, but not necessarily the same size. These are called similar figures. So if you look at A, B, and C, the triangles are similar because their angles are the same and their sides are what are called proportional. Okay, so right here is the most important part of this. Figures are similar when their angles are equal, when their corresponding angles, I should say. So corresponding angles are equal and corresponding sides are proportional. These are long words. Proportional. So the way we write this is that side AB, so the side that's in red up here, is proportional to side DE. So look how I wrote it as a fraction right here. Okay, so side AB over side DE is equal to side BC over EF, which is also equal to AC over DF. Okay, notice our angles are still the same. So angle B has one arc, and angle E has one arc, so those are equal angles. Angle A has 3 arcs, and angle D has 3 arcs. When I say arc, I mean these things right here. So matching number of arcs means the angles are equal. And C and F have 2 arcs, so those angles are equal as well. Notice the symbol right here. This delta symbol means triangle. So if I were to read this, I would say triangle ABC and a new symbol. We've used congruent before. Now we're going to use similar, and similar is just the squiggly part. Okay, so that means is similar to. So 2 kind of symbols you need to be familiar with. So let's look at example 1. And example 1 wants us to find out which rectangle is similar to rectangle A. Okay, so I'm going to set up my corresponding sides to be proportional. So this would be 6 over 6 equals 3 over 2. Okay, now there's a couple different ways you can see if these are equal to each other. So 6 over 6 simplifies to 1, and 3 over 2 simplifies to 1.5. So I know that those rectangle A and rectangle B are not similar to each other. Your other option is you can use cross products. So 6 times 3 is 18, and 6 times 2 is 12. And since 18 does not equal 12, they are not similar to each other. So I would say A is not similar to B. So now I need to try A to C. So instead of 6 over 6, it's going to be 6 over 4, because those sides are corresponding. So 6 over 4 equals 3 over 2. Now if you simplify both of these, 3 over 2 is 1.5. 6 over 4, if you divide, is also 1.5, or it's also 3/2. You could do it either way. Or if I use my other method, my cross products, 3 times 4 is 12, and 6 times 2 is also 12. So therefore, I would say rectangle A is similar to rectangle C. Make sure you use your symbols that we have learned. Now, in example 2, sometimes they will not give us every measurement, and we have to solve to find the missing one. So you still set it up the same way. So the corresponding side to 6 is 9. So I'd write that as 6 over 9 equals 8 over x. Okay, now your only choice here to solve this is to use your cross products. So 8 times 9 is 72. 6 times x is 6x. And then you are just solving a basic one-step equation by dividing both sides by 6. And 72 divided by 6 should be 12. All right, these next two you are supposed to do on your own. I'm going to be real nice and I'm going to help you set up number 2, but you're going to have to set up and solve number 3 on your own. So this one, these two sides are corresponding, so you would say 6 over 9 equals x over 6. Okay, so 6 over 9 equals x over 6. Now something to mention. Notice how I went from shape number 1 to shape number 2. I went 6 over 9, and I went back to shape number 1 equals x over 6. Okay, you can't mess up the order. Oops, this should be a number 2. You can't mess up the order or it's going to mess up your proportions. Okay, so always go back to your original shape. So 6 over 9 equals x over 6. Okay, go ahead and solve number 2 on your own, set up number 3, and solve it as well. And last example, example 3 says an artist draws a replica of a painting that is on the Berlin Wall. The painting includes a red trapezoid. So the shorter base of the similar trapezoid in the replica is 3.75 inches. What is the height of the trapezoid in the replica? So these pictures really are turned the wrong way because this is the base and this is the height. But this is the base and this is the height. So all I have to do is set up my corresponding sides. So 12 corresponds to h. So I would say 12 over h equals 15 over 3.75. Oops, 3.75. Now to solve, just use your cross product. So I have 15h is equal to 12 times 3.75, which is, in my calculator, 45. And now you're just solving a basic one-step equation, which you are dividing both sides by 15, which makes h equal to 3 inches. Now, whenever I solve a word problem, I always go back, or really any problem for that matter, and kind of plug it back in and see if that makes any sense. If you got an answer like 78, well, obviously 78 doesn't make any sense because that's bigger than the one you started with. Okay, so always kind of plug back in your number and ask yourself, does that make any sense? And in this case, it does. All right, the last on your own question says, what if the longer base in the replica is 4.5 inches? What is the length of the longer base in the painting? So my hint to you is to draw a picture. Okay, draw a picture of the replica and also draw a picture of the original painting. So draw a picture of the painting and the replica is my hint to you. And that is it for section 2.5.